we have a basic understanding of computer hardware and where the components of a program are stored during execution and where we execute, as well as encoding information into binary on a computer. Now let's talk a little bit about how we're going to be writing programs, and specifically how we're going to be developing Python programs. So the first question is, why can't we just write programs in English? Computers don't understand English, but why not? Well, English can be ambiguous. Our, with the sentence, I'm all about that bass, are you an avid fisherman? Or are you all about that bass? So written English can be ambiguous. So humans can't easily write binary either. And the very, very first programmers did program in binary. And gosh, it would be hard to make some of the programs we have today using just zeros and ones. I don't recommend it. So human language is too ambiguous, machine code is too tedious, so we need something in the middle. Enter programming languages. And our job is to translate the problem statement that we have in English into an algorithm solution or pseudocode, which we can then implement in what's called a high-level programming language such as Python. That then gets converted into bytecode, which Python interprets and turns into machine code, which then runs on our central processing unit or CPU. So a programming language includes specific rules for what is and isn't allowed. It has to be very precise and exact, so it's not ambiguous. And then the computer carries out the commands as they are given, for better or worse. The computer executes exactly what we tell it to, even if what we told it wasn't what we intended. The syntax are the symbols that are given by the language. So for example, a question mark in English indicates a question. A question mark is syntax, and its semantics is what it means. So a question mark means someone is asking a question. Similarly, if we see a symbol, an exclamation point, that's syntax, and the semantics means some kind of exclamation. And as another example, if we take the Roman numerals 3 times 4, that would evaluate to 12. Programming languages are unambiguous, unlike human languages. So the Python interpreter is going to validate our programming language expressions in Python, enforce Python syntax, and give us errors. So sometimes when we're typing in Python, we make mistakes. And unlike written English, because it's unambiguous, there's tools that exist that can automatically tell us when we've made a mistake. The Python interpreter also executes expressions, and it'll give us a couple different types of errors. Runtime errors, for example, if we divide by 0. In mathematical terminology, that is undefined, so that would be a runtime error. We tried to do something that we're not allowed to do. And semantic errors. Now, these are the errors that are the trickiest and that we most often come up against. A semantic error is where your program runs and gives you output, but it's not the output you wanted or the output you meant for it to have. So in general in Python, there's 3 types of errors: syntax, runtime, and semantic. One of the first things we're going to do in Python is to print. Printing is a special command or function which allows us to display information to the screen. It doesn't mean we're going to print to our printer that's attached to our computer. It's actually going to display to the screen. It also automatically adds what's called a carriage return or \n after it's printed. So for example, I could print hello class, and that will display just hello comma class to the screen. The information inside double quotes is known as a string literal, and we'll talk more about types in the next lesson. The syntax of this string is a set of double quotes, and the semantics is that it represents text. As another example, I can also print a string of text, your answer is, as well as a number. So the comma is a syntax, has syntax, and the semantics is to print multiple things on one line.